after discussing closed subschemes in the last videos, now we talk about particular types of open subschemes. And we have again seen everything before for the affine varieties. And if X is such an affine variety and F is a function on it, then we have this distinguished open subset dF, where F doesn't vanish. And it turned out that this was itself an affine variety. And the coordinate ring of this was just a localization of the coordinate ring of X at the element F. And the question is, what about the affine schemes? When we discussed the topology, we already saw that the DFs still make sense as distinguished opens, and now we give them the structure of a scheme in a particular way. So we see these distinguished opens as affine schemes. For this, let R be a ring and F an element. Then we have a ring homomorphism from R to its localization at F. And from this ring homomorphism, we get an associated morphism in the other direction of schemes like this. We call this IF. And the claim is that this is an open embedding with image DF. And if you recall, an open embedding means that on the level of topological spaces, this is just an open subset with the relative topology. And on the level of the structure sheaves, the structure sheaf here on this open subset is just a restriction of the structure sheaf here. So in other words, the spec RF is this open subset DF with the restricted structure sheaf from spec R. Okay, so let's see how this goes. First of all, let's talk about the level of sets. And there, so we want to understand what is spec RF. So somehow what are the prime elements in this localization? And then it's a lemma from commutative algebra, which tells us that the prime ideals in a localized ring are exactly the prime ideals of the original ring. So there's a one-to-one correspondence with the prime ideals of R, which do not meet the multiplicative set at which we localize. So here the multiplicative set are the powers of F. So we want prime ideals which contain no power of F, but for prime ideal this is equivalent to just saying that F is not in the prime ideal, like this. And this is, of course, just equal to DF as sets. Okay, and the bijection just takes a prime ideal here, and to get a prime ideal in a localization, you just take the ideal generated by this in the localization. Okay, so on the level of sets, we see that this map I, that the map IF is injective. Of course, we also know this is a morphism of local ring spaces, so it's also continuous. And the image is exactly DF, because somehow, like this abstract bijection here is, in fact, if you check it, is exactly this map IF above. And so we already know it's injective and continuous. So to show that's an open embedding, we now show that the inverse map is also continuous. So somehow inverse map so we start with something closed inside spec RF. So let's say V of J in here is closed. So somehow then J is an ideal of RF. Then we want to see that its inverse image here is closed, but the inverse image is also the same thing as applying IF. So somehow then what ideal could cut out this thing? Well, we can take J tilde to be phi inverse of J. Phi is this map from R to its localization. This gives us an ideal in R. And what you can check, and this is kind of the same stuff that we always do. So let's leave this as an exercise, is that if you apply this, then you exactly get the vanishing of this J tilde intersected with the F. And so, so somehow this also works in this direction. So the IF is closed. And so it's a homeomorphism onto df, and being a homeomorphism just means that for this injective map, the topology here is exactly the restricted topology from the image df. Okay, so this shows everything on the level of topological spaces. And the final thing that we claim here is that the structure sheaf on spec RF as an abstract scheme, as an abstract affine scheme, is the same thing as the restriction of the structure sheaf of spec R to this df. In other words, we want to show that when U in df is open, and there's two ways to define what it means to be a regular function. You can either take the O of this open subset or O of df and evaluate it at U, or you can take O of spec RF of this abstract spectrum on U. Note here, I mean, this thing by definition is just given by the restriction. So somehow this is O spec R of U. This. And we want to make our life simpler. We don't want to show this for any open set U, but let's observe that it suffices, oops, to prove this for a basis of the topology. And the basis of the topology, so somehow on spec R, the basis of the topology is given by the distinguished open sets. And then if we want them to be contained in df, for example, we can just, well, take the intersection of these things. And so, in fact, this just gives these open sets dfg. So this thing here is df intersected dg. So since the dg's are a basis of topology of spec R, the relative topology has the basis just intersecting all of them. And so why does it suffice to prove this claim? Well, because we use again the sheaf axioms. So somehow the sheaf gluing axioms as we have seen several times before, knowing all of the regular functions on these distinguished opens and how they restrict tells us everything that we need to know about the regular functions on U. So somehow the sections on U are equal to the sections on cover of U that agree on further covers of the FG I intersected the FG J. And so knowing that this thing here is an isomorphism, both on all of these things on the original cover, and then also an isomorphism on the covers of the overlaps, then implies that it is also an isomorphism if we have that these things, these are isomorphisms, then this implies that the I FU star are isomorphisms for all U in the F open. So that's just a small argument proving this claim. And then, well, now we have, with this little argument, we can restrict to such a U. And then there's these two different ways to compute the regular functions on there. So we can either compute them as restrictions from O spec R, but then this we have seen, this is just a distinguished open subset in O spec R. And so this ring of functions is just take the big ring R and localize at the functions defining this distinguished open set. So we just get this localization. On the other side, we have this spec RF, and then inside there, we have the DFG. But we apply the same result. We start with a big ring RF, and then we localize at FG. And then somehow doing these two localizations, since somehow this here divides this, it's the same as just doing the localization at the bigger thing. So we also get the same. And the map between them, somehow the map IF star is the identity. And so this is indeed an isomorphism, and this completes the proof. So what this shows, this was again a bit of this kind of bookkeeping math. What this shows is that the distinguished open sets are affine schemes themselves, and exactly for the ring that you would expect, namely for the localization of R at F. And with this, we have now done all the preparation, and so we can define what a scheme is.